Okay, 0.3b. Let's refresh the memory regarding factoring. Factor out the common factor. Okay, this is a GCF problem, greatest common factor problem. All right, so between these two terms, what can divide into both of those terms? Well, 5 divides into them, so you could pull out a 5. So I'm left with 5 times what is 5y? Y, 5 times what is negative 30, negative 6. And that's all you have to do. Done. For the next one, just refreshing the memory. Okay, looking at all the coefficients, what's the common divisor, greatest common divisor? Okay, well, it's going to be 2. Now, looking at the variables here, we need to pull out an equal amount from each term. So what's the most you could pull out? Well, I could pull out 1 from here, which limits me to 1 here and 1 here. So you're pulling out x from each term. Now what's left over? 2x times what is 4x cubed? Well, that's going to be 2x squared. 2x times what is negative 6x squared? That's going to be negative 3x. And 2x times what is 12x? That would be 6. All right, and that's all you have to do here. Because it just told you to factor out the common factor. All right, next example. Find the greatest common factor such that the remaining factors have only integer coefficients. Okay, since this coefficient is a fraction, I need to get it to be an integer. Well, what do you do then? Well, I pull out the fraction. Well, 1/3 times what is 1/3 y? Well, that's just going to be y. And then 1/3 times what is 5? Well, that's going to be 15. Okay, because all you have to do is take 15, divide it by 3, and you get 5. All right, that's all there is to this one. Done. Next example. Completely factor the difference of 2 squares. Recall that the difference of squares is this structure, a squared minus b squared. And that factors into a plus b times a minus b. Now the order of the operations doesn't matter. It's the same thing. All right, so in this case, what's my a, what's my b? Well, I need to rewrite this whole thing as a square here. So I have 2 squared over 5 squared y squared. That can be written as 2/5 y, and the whole thing is squared. All right, then I have 64, which is 8 squared. All right, so 2/5 y is my a, and 8 is my b. So I have 2/5 y plus 8, and then 2/5 y minus 8. All right, factored the difference of squares. Done. On to the next example. Okay, here they're asking you to factor the perfect square trinomial. They told you it's a perfect square trinomial. This is the structure of a perfect square trinomial. Okay, so what am I going to get from this? Well, I have to rewrite the first term as a square. So first term is going to be 3x, the whole thing squared. That results in the same thing that we have up here. And then the 4, that's no problem, it's 2 squared. The middle part is what gets tricky for students. Okay, well, my coefficient here has to be 2. All right, and my a value has to be the same as what I have here. Okay, so I have 3x for a, and then b has to be the same thing as what I have over here. That's my b, so that's times 2. So that's the general structure here. So where is this coming from? Simply from this formula here. You already know what your a and what your b are, so then you just fill it in right here. Okay, so we have the perfect square trinomial structure, and then that simply factors into a minus b squared. Well, what's a? 3x, and b is what? 2. So we end up with 3x minus 2 squared. All right, so the perfect square trinomial has been factored. Done. Next example. All right, factor the sum or difference of cubes. This is a very easy factoring problem, but it tends to be a challenging problem for students. But this is all you have to do. Remember this acronym, SOP. All right, so S stands for same, O stands for opposite, and P stands for plus. Okay, now you have all this information on your yellow sheet. You'll be able to use it on the chapter exam. All right, so just make sure you're familiar with the yellow sheet. All right, now applying this idea, here is the formula for a sum of cubes. So it starts off with the binomial, A, B, and then starts off, or the second piece is a trinomial, A squared minus A times B. All right, so let's take away that minus. I'll explain where that comes from in a moment. All right, and then we have B squared. All right, so this is the general structure for the sum or difference of cubes. Now, what are the signs? Well, that's where this acronym comes into place. Same means the same operation as what you started with the sum of cubes. So it's plus. O for opposite. And then P for plus. So we always end with a plus. All right, so there's the general structure of a sum of cubes that's factored. So let's figure out what the A is here. I'm going to have 3x cubed. And I'm going to have 2 cubed. So 3x is my A, and 2 is my B. Let's just fill it in. So you have 3x plus B, which is 2. Then you have A, which is 3x, and then we're squaring it. They got minus 3x times 2, squeeze it in there, plus B, which is 2, squared. All right, and just polish up the trinomial that's left over. So we have 9x squared minus 6x plus 4. All right, that's all there is to it. All right, so if it was a difference of cubes, if you had a difference here, then this would be the same, opposite, and then plus. All right, that's all there is to these problems. Next example. Factor the trinomial. Now there are so many different methods I've seen for doing this type of problem, but this is the method I always use. I call it the big X method. But with whatever method you were taught, usually this is what's going on behind the scenes. Now this is a very precise method. I've seen a lot of students play guessing games with these types of problems, but if you use this method, it'll usually take you to the right answer every time. Okay, so how does it work? Well, above the x, I'm putting negative 13. That's my b value, okay, negative 13. Then I'm going to put c on the bottom. That's my 42. All right, I need to find two numbers that add up to negative 13, but multiply to give me 42. Now, you may be able to see how to do this in your head, but if you're having any trouble, you could always start off with 1 and just ask yourself, well, what do you add to 1 to get negative 13? That would be negative 14. Now, if you multiply these, you're not going to get 42. You're also going to get a negative number, and this isn't negative. So what do you do then? So instead of starting with 1, positive 1, you start with negative 1. All right, now what do you add on to negative 1 to get negative 13? Negative 12. If you multiply those, you don't get 42. So then you move down with the negatives. Negative 2 plus what is negative 13? It's negative 11. And then you just keep going until you find the right combination. No. There we go. So negative 6, negative 7. All right, works every time. So then our trinomial simply factors into the product or the multiplication of two binomials. You start with the variable for each binomial, which is x in this case, and then you just fill in each binomial with the numbers we came up with. negative 6, negative 7. All right, that's all there is to it. Pretty easy once you get the hang of it. Next example. All right, factor by grouping. How do you do that? Well, you group the first two terms, and then you group the last two terms. And then you find the greatest common factor for each group. So for the first group, what's the greatest common factor? I could pull out a 5, and I could pull out x squared. What's left over? I have x, and then I have minus 2. All right, out of the second group, what can we pull out? I could pull out a positive 3, and that'll leave me with x minus 2. And you always want to end up with the same thing. All right, now what can I do here? I have two terms that I'm working with. And what do those two terms share in common? X minus 2. So pull that out from the whole expression. Factor it out. X minus 2. Now what's left over? 5x squared and positive 3. All right, now we've factored this 4-term polynomial. Done. All right, factor the trinomial by grouping. All right, so this is what you need to do. Same thing that I showed before when we factored the trinomial in example 6. All right, so I'm going to take my b, put that on top. And I'm going to take my c, put that on the bottom. But I still have to multiply that by the leading coefficient. Because in example 6, this was 1. All right, so we didn't have to worry about it. But since it's not 1, we have to utilize it. So I have to do 2 times 9 on the bottom here, which is 18. All right, now what two numbers add up to 9 and multiply to give you 18? 3 and 6. Now with this type of problem, this is the classic mistake I see from students. They do this as their answer. All right, do not do that. That is incorrect. All right. It doesn't work that way because our leading coefficient is not 1. So there's a little more involved in factoring this trinomial. So the first thing I have to do is write the first term. And the middle term is going to break up using these two values. All right, so the middle term breaks up into 3x plus 6x. And then I have the last term, plus 9. All right, so now I have a 4-term polynomial. And how are you going to factor that? Well, 4 terms. Let's use the grouping method. We're going to group. All right, what can we pull out of the first group? We could pull out a x, leaving us with 2x plus 3. And out of the second group, you could pull out a 3, leaving you with 2x plus 3. All right, now I have 2 terms. And what do those 2 terms share in common? 2x plus 3. And what's left over? X plus 3. All right, and now we're done factoring. All right, done with the lesson. Start the assignment below.